Yeah. Good evening, everyone. Switch on your cams. Let's start off. Great. So we're meeting again after almost 2 months. Chalo, others cams on. Yeah. So few things before we start the session. First thing, please make sure your cams are on and your face is visible on the screen. Right. So yeah, in case you need to use washroom or something, yeah, you can go switch off your cam, go and come back in a minute or two. But if it is more than that, I'm going to remove you from the classroom. Getting it? Or you can just leave me a message. But anyway, I'm going to give you a small break in the middle. Right. And anyway, this week I will not have maybe 2 hours. Maybe we'll just have like 1.5 hours or something so that you get used to it a little. But from next week onwards, it'll be full-fledged 2 hour, 10 minutes or something. That is one. Second thing, don't worry about, writing down the whole notes, right? You can have a notebook. You can put down, some important points and stuff because I'll send you this PDF. Whatever I'm writing, I'll send you the PDF. So what I want you to focus when I give you a question, I want you to just start solving, getting it? I want you to use all the time to think, to understand, and to figure out, okay, what is happening with the question. Don't waste your time writing the question, making a beautiful notes. Like I said, JE people really don't care how beautiful your handwriting is. Because if you see the questions, right, you have a question and there are 4 options. And you mark the right option, you get marks. Like there is nothing about your handwriting that no one cares. So that is one thing. And right. And during the session, anytime you have a doubt, you can always unmute and you can directly ask me, right? If you don't understand something. But if I give you a question, right, and I'm expecting an answer, please don't unmute and shout an answer because I want others also to try. So what you can do instead, you can see I have 2 logins. One is the host and one is the co-host. I just said hi in the chat box in Zoom. You can type your answer there. Getting it? You can type your answer personally or open, up to you. If your answer is right, I'm going to say it is right. So, right. So let's keep these two things. You have a doubt, you can just unmute and ask, or you can type a message. Right. I'm looking at you. Right. I have a desktop in front of me. I'm looking at you, all of you at the same time. Right. And I have a tab here. I'm writing. So there are 2 logins. So you have to reply to the co-host, not the host. Getting it? Yeah, that's it. So if you have a doubt, please don't hesitate to ask. But in case you're hesitating, you can always stay back end of the class and get your doubts cleared. But important thing is that please get your doubts cleared. First of all, don't hesitate. No one really cares here. But still, if you hesitate, please don't mind. Don't hesitate. Ask. At least stay back till the end. So, okay, great. So today, right, what we'll be starting off. The first thing is we call it basic maths for physics. Now, this is not officially a chapter of JEE syllabus, but the problem, is uh, in by the time the max people actually teach you the concepts of the trigonometry or calculus or something, it will be too late. But in physics, we need all this mathematical stuff to figure it out. So what I'll be doing, I'll be teaching you all the math that is required for physics, right? And then we will go ahead with a chapter called vectors and so on. So that is how we will take it ahead. So great, let's start off. Just a minute. Let me take the attendance. Shrikant, can you just keep your cam on? Yeah, perfect. Yeah, attendance is simple. I just take a photograph and send it to Mimi, ma'am. She checks out, and whoever is missing, you get a call. So great. So let's start off with something simple. We'll start off with angles. Again, remember, we are not a max class. We are mostly interested only in the applications, how we got the formula, what is the derivation for the formula. We are not going to handle that in physics. So this we did a bit in foundation also, but few things will be repetitive from foundation. So those are already there. Fine, you can just listen once more. I'm pretty sure you must have forgotten after your board exams. You remember, that is great. But anyway, it won't be long. So if you have a circle, so this arc here is your arc length. We define it with a symbol S. This here is your radius. So we define something, the angle is simply a ratio of the arc length by radius. That is the definition of an angle. So which is simply S by R. So arc length is given by R into theta. Now one thing you have to be careful here, theta must be in radians. What is that? So this is a conversion unit. Pi radians is 180 degrees. So this is how you pronounce this. You call this thing as pi radians. It is just a conversion factor. Think of like this. What is 1 kilometer? 1,000 meters. So that is kilometers. This is in meters. What is 1 meter? 100 centimeters. What is 1 meter cube? So centimeter cube. It's just a conversion factor. So 1 radian will be 180 degrees by pi. So if I give you radians, you can convert into degrees. Or if I give you in degrees, you can convert into radians. Now, this is important. So whenever you write angles, right, generally we always stick to radians. We don't write them in terms of degrees. So just to give an example, if you have 150 degrees, so this is 150, you can use your unitary method. If 180 degrees is pi, then how much is 150? I hope everyone knows the unitary method. So you can do that and get it. So that would be 150 and 1 degree will be pi by 180. That is 5 pi by 6. There. I hope that is making sense. You know how to convert radians to degrees and degrees to radians. So suppose if you have something like 240 degrees. So this is 240 into pi by 180, 4 pi by 3. Same way, you can do the reverse also. I give you pi by 4 radians. So this is 180, pi is 180 by 4, so 45 degrees. If you say pi by 18, that's 180 by 18, so that's 10 degrees. Clear with this? Easy stuff. Any doubts on this page? So when you write arc length is a radius into theta, you have to be careful. Theta should not be in degrees. Theta must be in radians. That is the main theme of this thing. All clear with this? Tanmay, Prisha, clear with this? Ahana, Aniket, clear? Great. So let me just show you one example and we'll go ahead. So if you have a circle, let's say the radius of the circle is 3 meters. And let's say this angle is 120 degrees. And someone is going to ask you, what is this arc length? So arc length is this curve ka length. Now, what is the formula? S is equal to R theta. So R is 3. Now, here, this is what I was saying. Theta, you should not write 120. So theta is 120 degrees, but it should be converted into radians. So that's 120, and 1 degree is pi by 180. So theta is 2 pi by 3. So you should be writing here as 2 pi by 3, and that will be 2 pi meters. All clear how to use this? Clear with this? I hope everyone is clear with this part.
Please explain it again.
So here theta is 120, right? So convert 120 into radians, that is 2 pi by 3. So what is the arc length here? Radius into theta. So 3 into 2 pi by 3 is 2 pi by 3. Sure, Ananya?
Yes, sir.
Great. So that's it. It's a simple concept there. So this is how you find an arc length. So let's see a question on this. Now, no one is going to ask you like this in the exam, right? That's what I'm saying. This is a concept. In physics, that's what you will see. You know, the concepts will be pretty straightforward. So let's start off with a simple problem there. Let's say we have an equilateral triangle. Right? And let's say the side is 1 meter. I hope everyone knows the properties of an equilateral triangle. So in physics, right, there are few shapes, which you should be very thorough with this. Equilateral triangle, a circle, a square, a parabola, and, a hexagon. So we'll talk about hexagon and parabola later on. But in case you don't remember, I'll just brief up the properties of equilateral triangle. So if you have an equilateral triangle of side A, so if you drop a perpendicular bisector, this is your height. So this is your height, which is given by root 3a by 2, if a is the side. The centroid here will divide the height in the ratio of 2:1. That means this upper length will be 2/3. I hope everyone knows how to take the ratio, 2/3 of the height, which is 2/3 of root 3a by 2, which comes out to be a by root 3. And this will be 1/3 of the height, which is 1/3 of root 3a by 2, which comes out to be a by 2 root 3. I hope this much everyone knows, right? You studied in school equilateral triangles. So in case you don't know, you can just note it down. That's what I'm saying. Whichever things you think you don't remember, you don't have an idea, so make a just rough thing, on the side, because we are going to need this for the questions. You remember, great, no need to write. So everything that I'm writing, right, if you're like, fine, you understood, there is no need to write, it is fine, because you'll get the notes. But you don't remember this, just have a book beside you, just write it down and keep it there, because I'm going to use this for the next question. And this is what I was saying in yesterday's seminar also. Whatever I teach you, that will keep on piling up, right? Great. All clear with this? So let's see a question. So we have an equilateral triangle of side A, and let's call these points A, B, and C. So now what you did, you started ruling this triangle. The triangle is rolled on the floor, right? Just like a wheel without slipping. Let me show you how it would look. Find the total distance traveled. In one revolution. So how is this guy ruling here? See, this is how the picture would look. So initially the triangle was here, A, B, and C. So when you are ruling, think of like this. If you are looking into my screen, look into my screen. So let's say my phone, which is there, again, this is not a triangle, but a rectangle. Think of like this. So this is how it is rolling. Huh? Can you see how it is going? Like a wheel. But instead of a proper wheel, it is rolling on the edges. So it will roll about this edge, it will fall. Then it will roll about the edge, it will fall. Then it will roll about the edge, it will fall. Are you getting how it is rolling? So this triangle is rolling on the floor. So it's not a proper wheel, it's a triangle, right? So this is how the picture would look. So the next moment, when it tries to roll, so A will be fixed on the ground, but this A, B, C, right, are going like this. So B is coming here, C is coming here. So B is going something like this, and C is going something like this. And then this thing falls on the floor. Then your triangle becomes like this. So A comes here, C comes to the top, and B comes to the ground. Then again, this will roll on the floor. But this time B will be fixed on the ground. This will be C, this will be A, and as this thing rolls, this will go and fall on the floor here. This point will become A, and this point will become C. I hope you can see how this thing is traveling here. So A is going like this. And eventually it will come back to the initial position. So in one full revolution, I want it come back to A again. So when it rolls again, it comes back to the point A. So how much distance did point A travel? Is the question clear, everyone? Try. I'll give you 2 minutes. Again, don't write the question. Don't waste your time there. Focus on solving. Have a book and pen with you. Maintain a book so you can do all the questions in that. So someone made a wheel like a triangle instead of a proper circular wheel. And so this thing is toppling. The technical word for this is called toppling. So the word here is toppling. But okay, that's fine. So when you make one full revolution, what is the distance traveled by A? Think for a minute or two, then we will see. Okay, Karthik has one answer. Ananya, that is wrong. Anyone else? Any more answers? You can, like I said, you can type to the co-host here. I just said hi there. You can send it there. Anish. Right, Anish, we have two answers. Anyone else? It's completely fine if you don't get it. Don't panic. It's like I said, the 1 or 2 minutes is for you to try and think. You don't get it, I am there to explain you. So you will learn. It will take time. You will learn. You'll get used to it. Don't worry about it. But try. Give your best. Nee, Rohit. Maybe you can simplify that a bit. Yeah, even then it is wrong. Okay, let's see. I'll show you one. Listen. Let's just draw the picture, okay? So initially, this was the triangle. So this was A, this was B, and this was C. So in the first turn, when you turn it for the first time, right, the triangle will become like this. So C will come to this position, B will come to this position. Agreed? This is the first turn, okay? Not revolution, first turn. Did A move? Did A move? A didn't move, right? A is at rest here. A did not move. So yeah, in the first turn, A did nothing. Great. Now, second turn, I'm just drawing multiple pictures here. Later on, we don't need so many pictures, but yeah, for the first time, let's see. So A, C, B. Now tell me, now when you're turning about this, you're turning about which point? Now the picture will become like this. This point will be A, this point will be C. Do you guys agree with this? Now, when you're doing this, it feels as if B is the center and this point A is going in a circle like this, isn't it? So this whole system, right, it rotates about point B. So all the points, point A and C, move in circular arcs. With B as a center. So B behaves like the center, it goes like this. And what is the radius of the circular arc? Radius will be 1 meter, isn't it? That is the side of the triangle. And what about this angle here? Now, ask yourself, what is this angle here? In an equilateral triangle, this angle is 60 degrees. Agreed? The total angle is 180. So 180 minus 60 is 120. So that means A here moved in a circle of radius 1 meter and an angle of 120 degrees. Is that making sense, everyone? All clear with that explanation there? Right? So what is the distance traveled by A? So here A travels, in this turn, A will travel r into theta. Again, the same thing, r is 1 meter. Theta is how much? 2 pi by 3. You should not write 120. So it is traveling 2 pi by 3 meters in the second turn. Any doubts on this part? Please ask me. So this is your second turn. And you should keep doing this till A comes back to the ground, isn't it? Now, if I do this again, right? This was A, this was C, and this was B. Now, when you turn, so you become something like this. So this point will become B, and this point will become A. Now, what is happening? Now, C is behaving like the center, and A here is going in one more circle from A to A again here. Again, this angle is 120 degrees. And again, this thing is acting like a radius of 1 meter. So again, it will travel a distance of 2 pi by 3. So therefore, total distance of A is 2 pi by 3 plus 2 pi by 3. 4 pi by 3 meters. Is the explanation making sense, everyone? So when this guy is rotating about the edge, it behaves as if the other points are going in a circle. The side will become the radius and the angle here coming 120 degrees. Now that's all geometry there. Any doubts on this? Anyone not convinced with this? Please ask me. Shrikant, Rohit, clear? Trisha, Aniket, Daksha. Daksha, clear with this? Dave, clear. Great. So you got this? Let's see one more like this. Same equation, but this time I'm going to make a square. This is a square of side 1 meter. A, B, C, and D. So it rolls on the floor without slipping. Find the distance traveled by A in 1 revolution. The story is the same. So be careful with the words revolution and turn. Okay, turn is simply you're going from one alphabet to another. A revolution means you come back to the same position again. So the distance traveled is 4 pi upon 3, while the displacement is 2. Yeah, displacement is different. So we didn't ask for displacement in the previous case. Yeah. If they had asked for displacement, it would have been 2. Let's see how we do this thing. So I taught you one model, right? The model is similar. But, yeah. Arya, I can't see you. I think your cam is not working. So please do something about it in the next class. Arya, are you there?
Yes, sir. Actually, I don't know why the camera is not working.
ठीक है. So figure it out next class, get it sorted.
Yes, sir.
Nee, Karthik, that's not the answer. Nee, Anish. Nee, Ananya. Nee, Rohit. All of you fell into the trap. I think Aniket. Nee, Aniket, you also goofed up. Hana, no. 2 plus Prisha. I think Prisha got it. Yeah, Prisha got it. What is the trap here? You guys are forgetting something here. Again, let's draw the picture and see. I know you guys will do this. You guys took the equilateral triangle and you just extrapolated it without thinking. So this was A, this was B, this was C, and this was D. So the first revolution, right? Nothing happens. So you will come like here. This point will become C. This will become D. This will become C, and this will become B. So there is no distance traveled here. Now for the second thing, this would be A, this is B, this is C, and this is D. Now B will be the center. A will be the radius, which is 1 meter. And your picture will become like this. A will come here, D will come here, and C will come here. And we can clearly see A goes in a circle. And what is this angle here? 90 degrees. I hope that was clear, everyone, right? So every time you take a turn, you rotate by 90 degrees. And what is the distance traveled here? 1 into pi by 2. Perfect. Next time, this is where most of you goofed up. This is C, this is D, this is A, and this is B. Now when you make a turn, your shape is going to be like this. This will be B, this will be A, and this will be D. Now A is going from here to here. Agree, it is still going in a circle. But is the radius still 1 meter? Now the diagonal is the radius, isn't it? And what is the diagonal of a square? √2. This will be the radius. It is not 1 meter anymore. You are going in a bigger circle. Did you guys got that? It's not 1 meter every time. So what is the distance traveled here? √2 times into pi by 2. Then the last one will again look similar. So this will be D, this will be A, this will be B, and this will be C. This would be C, this would be B, and this would be A. So again, you go in this circle here. So that would be 90 degrees and 1 meter. So again, you travel 1 into pi by 2. So therefore, the total distance will be 1 into pi by 2 plus √2 into pi by 2 plus 1 into pi by 2. That's pi by 2 into 2 plus √2. I think, yeah. Check your answer, Prisha. Got it? Who else got it? I think Anish also got it now. Karthik also got the mistake now. I hope you got the mistake here. Now, this question, right? Great, we did it by drawing pictures, but you could have done it even better. You could have done it a little faster by making a small argument. So listen to this argument. This will help if you're having more shapes later on. So in physics, right, there are two things, there is something called visualization in space and visualization in time, right? Visualization in space is you're seeing the structures, and you're trying to imagine like this. Imagine you're standing in the center of a sphere. It is a big hollow dome and you're standing in the middle of it, right? Now, when you look straight up, you can see that North Pole kind of thing, right? That's a point there. Now, from there, if you rotate 60 degrees to the right, you can see a point there. You are imagining how things are moving on a dome or something. The second thing is visualization in time. So we will see questions on that also. You'll get the hang of it. Visualization in time, right, is like you take a scenario and you try to, fast forward the time and say, like, how is this going to look after some time? Best example, you do this every time. Imagine in your house, you break your TV. Let's assume you don't do that, but you break your TV, right? Then you start visualizing, isn't it? What is mom going to say? Will mom and dad come and start punching me? Are they going to beat me? What are they going to say? You are actually visualizing what is going to happen in time. So we can do something similar here. So look at this. Look at the argument here. when you take A, B, C, and D, when you do the first turn, this point becomes a D, this becomes C, and this becomes B. Now, this is the argument here. You can clearly see D is going from here to here. You can clearly see C is going from here to here. And we can also see B is going, from here to here. So whatever D is doing right now, A is going to do that in the second turn, isn't it? Whatever distance D traveled, isn't A also going to do that same thing in the next turn because A will go to the D ka place? Whatever C is doing right now, A is going to do that in the third turn. Whatever B is doing right now, A is going to do that in the fourth turn. Do you guys agree with that? If you go back to the pictures, A was occupying D ka place in the second turn, A was occupying C ka place in the third turn, A was occupying B ka place in the fourth turn. So can I make an argument that distance traveled by D, C, B in the first turn is the total distance traveled by A in one revolution? So there is no need for me to draw the picture every time and show it to you. I can simply say whatever D, C, B are doing in the first turn, right, must be equal to the sum of, that sum must be equal to the distance traveled by A in one full revolution. Because whatever D, C, B are doing now, A is going to do that later on. Distance traveled by B, D, C, and B in first turn will be the distance traveled by A in one revolution. So basically, this is what happens. So A behaves similar to D when it is doing the second turn. A behaves similar to C in third turn. A behaves similar to B in fourth turn. So with this argument, you can directly say all of them are rotating 90 degrees, right? So A ka distance is 1 into pi by 2, that is D ka distance, root 2 into pi by 2, and 1 into pi by 2. So this is for D, this is for C, and this is for B. That would be pi by 2 into 2 plus root 2. Is this making sense? Right? So instead of looking at it each one individually, you can just figure it out that way. Any doubts on this? So I'll give you one homework question. You can give it a try. Next class, we can check the answer. So what if I have a regular hexagon? What is a regular hexagon? All the sides are equal. Whenever you see a regular polygon, it means all the sides are equal. So this is a regular hexagon. Side is A meters. So answer will come in terms of A. This is A, this is B, this is C, D, E, and F. Right? Same story. Find distance traveled by A in one revolution. Now, how does a regular hexagon work? So I'll give you a little data there. So a regular hexagon is nothing but 6 equilateral triangles. So if you take a regular hexagon, A, B, C, D, E, and F, and if you join the opposite ones like this is actually made of 6 equilateral triangles. So you can use this. So this is 60, this is 60, this is 60, and let's say O is the center. So all these will be equilateral triangles. So if this is side A, this is A, this is A, this is A, this is A, all are A's and all are 60 degrees. right? So you will need this. Uh, you also need to prove certain things. So you try to prove this. So BF will be root 3a. You need to prove this. And CF will be 2a. So you will need this information to solve this question. So, but try to prove these two things. I'll be teaching you how to. We can do that also. We have to use a little trigonometry there, but can be done. Question is clear. So idea is the same. You can give it a try based on this. All clear with this? Let's see one more question. This is the top view. You're seeing this from the top. We got a fixed square. Right? And for this fixed square, we have a string. The length of the string is 15 meters. I'll tell you how the picture looks. Think of like this. If you're looking into my screen, so let's say what a wire here. You're looking this from the top. So think of like this. So this is the square, okay? This is the book. So what happened here? We have a rope like this. Can you see this rope? So we got a rope like this. And now what happens? So it's like this thing, okay? And someone pushed it with a speed. So this rope, right, started going around the square. So that's like this. And this rope, it started going around the square. It started tying it up. You can see how it is going around it. It's actually hitting this. It's becoming forming here. It's forming here. So it is going round, 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 around this thing. I guess able to visualize how it is going. So you're seeing this from the top. You're getting it. So if you look at from the side view, it looks like this. So if this is the rope, when you give a velocity, it goes like this. So it hits, it goes here, then it goes here. So it is wrapping around the square. I hope that's making sense. I'll still try to show you some pictures. So this is how the diagram would look. You're seeing this from a top, matlab it is on your floor, and this is what is happening. So this thing will try to go in a circle. So when it goes in a circle, it will become like this. Then it will try to go in a circle. Then it becomes like this. Then it becomes like this. So if you look at this guy is actually going in a spiral. So it goes in a spiral here. Then it goes in one more spiral here. Then it goes in another spiral here, and so on. It hits the thing eventually. Making sense? So this is the fixed square of on a smooth table. The side is 2 meters. So the string here wraps around the square and keeps moving. So it kind of looks like a, a spiral. The string wraps around the square. So it becomes smaller and smaller. Find the distance traveled by this particle. So this is the particle here. So someone gave some speed u. Speed doesn't matter. You just throwed it and this thing started going round, 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 round. Find the distance traveled by the particle and the position where it hits the square. So it will go and hit the square at some position. Which point is that? Anyone didn't understand the question, please ask me. And again, understand one thing. What did I teach you? I taught you only one concept, S is equal to R theta. That's it. I didn't teach you any out of the world physics or big mathematical concepts. We're just playing with what you learned in school, and S is equal to R theta. That's it. But everyone realized, right? This thing is actually going in a circle, but every time it hits the square, radius becomes less. I hope everyone figured out that part. So your radius actually decreases every time by how much? 2 meters. Right, Anish, you have an answer. Where does it collide though? You can tell me, like, right wall ka mid, upper wall ka mid, bottom left, you can say something like that. Right. Right, Karthik. Aniket, right. We have 3 answers. Others, try. I'll give another 30, 40 seconds. Again, please remember this. If you don't understand the question, it is my fault. You don't know how to do, that is okay. Give it a try. Try for 2-3 minutes. I'm there. I'll explain you. You'll figure it out. That's okay. The question should be clear. If you're not didn't understand the question, it's my fault. Right, Karthik? Rohit, no, Rohit. You got the collision point right, but your distance is messed up. Okay, let's see. Again, you just have to draw the picture carefully here. So if you have noticed here, we observe this guy goes in a circle whose radius is always decreasing by 2 meters. So initially it was 15 meters. By the time you do the second turn here, you lost 2 meters. So this is only 13 meters. Next time you do this, you have only 11 meters. Next time you do this, you have only 9 meters and so on. So we can clearly see it goes in a quarter circle. So if you see, and again, all these angles are 90 degrees. It's every time you rotate only 90 degrees before your radius changes. So this particle goes in a quarter circle whose radius decreases by 2 meters. That is the thing you need to figure out. So once you got this, the distance traveled, so pi by 2, remember the formula, r into theta. So all of them have same 90 degrees. So pi into, first one will be 15 into pi by 2. Next thing will be 13 pi by 2, 11 pi by 2. I can keep doing this so on, 1 into pi by 2. Take it pi by 2 common, you end up with 15 plus 13 plus 11 plus 9, so on till 1, right? And this would be, if you add it up, you end up with 32 pi. That's an AP, right? I hope you know how to add an AP, arithmetic progression, you learned in school, but you can just add it up, right? And where do you collide? You can clearly see this thing, you keep reducing 2 to 2. You have 15, so you'll make 7.5 turns. So the last picture, right, would look like this. So basically you'll cover 2 meters, 2, 2, 2. So that is 8 meters. Then when you go for the second round, 10 meters, 12 meters, 14 meters, and the 15 meters, you are going to collide here in the midpoint. That's what will happen. So the last 1 meter will be this. The collision will happen on the left-hand side, come midpoint. You can check it out manually. All clear with this? Great. So,
Sir,
Dev.
can you please explain that the place where this meets?
You can count it, right? Every time you complete 8 meters, if you do 2 rounds, you'll get 16 meters. But you have only 15 meters. So you're 1 meter short of coming back here. So that is the midpoint here, right?
Thank you, sir.
Got it? Yeah. So yeah, I'll give you one more, like this homework, you can give it a try. So let's say this time instead of a square, you have a triangle like this. 3 meter, 4 meter, 5 meter. This is the fixed right angle triangle. Top view. Same story here. So here the length of the string is 33 meters. So this thing starts going around, the same story. Find the distance traveled by the particle and the point where it collides. You can try this as a homework. So the square was easy, right? Here I messed up the side. So every time you collide, you will change by different distance. So it becomes slightly more complex. You can give it a try. Next class in the beginning, we will discuss these two questions though. Got this? So see, this is how applications will be. No one is going to ask you, radius is 2 meter, theta is this, find s. So you will never get questions of that sort. Like I said, physics may we use max. Max is just like a tool. Now, how you can, form questions and all is a different thing. So, but there, I didn't teach you anything new. The only thing you learned so far is s is equal to r theta. Clear? Great. So let's continue more. Let's take more concepts. Now, next thing is your basic trigo you learned in school. So if this is your angle theta, this is your opposite side, this is your hypotenuse, this is your adjacent side. This stuff you know. I'll just brief it up. So sine theta is your opposite by hypotenuse, which is 1 by cosecant theta. Cos theta is adjacent by hypotenuse. Yeah, the standard stuff. And other than this, we also have some standard identities. Sine square theta plus cos square theta. These things are pretty common. Like they just keep coming in physics like normal letters. Sec square theta minus tan square theta is 1. Right. Other than this, now in Max, right, you have a full chapter called trigonometry. They'll teach you for more than a month. They're going to do in very detailed. We don't need all that stuff for physics. So we will, like I said, we're not going to do any derivations, nothing. We will just use them. So sine A plus B, the formula is sine A cos B plus cos A sine A, sine B. So the derivation of this, if you make A is equal to B, this will become sine 2A. This is important. This will keep coming multiple times in physics. 2 sine A cos A. Example. Let's say if you have sine 60 degrees, I can write this as sine 2 times 30, which can be written as 2 sine 30 cos 30. Again, these things you need to remember. There is no explanation or anything like this. So this is A. So basically 2 sine A cos A. Sine 30 is half, cos 30 is root 3 by 2. There we saw sine 60 is root 3 by 2. Like, I'm not trying to prove, I'm just trying to show you how it looks. So there, this result is important. This will come in physics at least maybe 7 to 8 times. The next one, the most important identity, cos square theta is 1 plus this. This will literally come like 15 to 10, 15 times like. And when it comes, I'm going to tell you, and I'm pretty sure you must have forgotten. Happens every year. So this you'll start seeing from the next chapter only. 1 minus cos 2 theta by 2. So this is a very beautiful way of converting a square function to a single cos power 1. Right. So anyway, not a big deal. It's not a big concept or anything. Max made as a joke, but physics may use it a lot. So cos 2 theta is cos square theta minus sine theta. It is all the same thing. I'm just I'm just modifying it in different forms. 2 cos square theta minus 1 or 1 minus 2 sine square theta. But in this, and these two are the most important ones. You will see this thing n number of times. You should definitely remember that one and the sine 2a. All clear with this? You can put on the things in the red box if you want. Okay. Can I go ahead? Ishi, go ahead. Tanmay? Great. Then, other than this, we also have tan ka thing also. These are little rare. Maybe you will see once or twice. Tan A plus B is tan A plus tan B by 1 minus tan A tan B. Tan A minus B is tan A minus tan B, 1 plus tan A tan B. And other than this, you need to also remember the table there. Sine, cos, tan. So if you have a 0 degrees, 30 degrees, 37 degrees, we also study for 37. It's a good number, so that's why you study it. 37 is not really some super special or something. 53, 60, 90, 120, 150, and 180. I messed up. 135 also is there. At least that's it. We just need to remember these many values. There, you'll also sometimes you might need more than 180, but max people will teach you by then, so we are not really that concerned. So sine 0, 0, sine 30, half, sine 37, 3 by 5. So if you can remember them, no need to put it down. So the only new things are 37 and 53. I'll tell you that also how to remember. Root 3 by 2, 1, root 3 by 2, 1 by root 2, half, and 0. This is 1, root 3 by 2, 4 by 5. So cos becomes negative in that quadrant there. Tan 90 is infinity. Minus root 3 minus 1 minus 1 by root 3 is 0. This much values you should remember. So how do we get the 37? 37, right, actually belongs to a 3, 4, 5 triangle. This angle is 37 degrees and this angle is 53 degrees. So sine 37, opposite side 3, hypotenuse 5. Cos 37, 4 by 5. Tan 37, 3 by 4. Sine 53, 4 by 3, 4 by 5. So it's a 3, 4, 5 triangle. That's it. So the number is good. So we use the 37 and 53 also quite frequently. As such, there is nothing great about 37 or 53. But these are the angles which you will keep seeing multiple times everywhere. So you should know this stuff. Clear? Great. Now, other than this, we also have something called a sine rule. So if you have a scalene triangle, this is angle A, this is opposite side this thing, this is angle B, this is angle C. So the capital letters are the angles and the small ones are the sides. So capital A and capital B, capital C are angles. Small a, small b, small c are sides. So the side opposite to angle A is the side A. Angle opposite to B is small b. This is for any triangle, okay? So we have two important rules here. We call this thing sine rule. This thing says the side by the sine of the angle opposite to it. So A by sine of this angle is equal to B by sine of that opposite angle, C by sine of the opposite angle. This is constant. This is valid for any triangle. You take a side and you divide by the sine of the opposite angle, they'll be always equal. It's called sine rule. How we got it, we are not worried about it. Let max people take care of it. Useful? Like I said, it's all mathematical tools. Cosine rule, cos A, the formula is b square, c square minus a square. How can you remember this? Easy to remember. Cos A, so forget about A, take the other two guys, b square, c square, and subtract a square there. So they actually form a sequence. If you do cos B, you can guess now. It should be a square, c square, subtract b square by 2ac. This is a square, b square minus c square by 2ab. So when they use sine rule, let's say you know two angles and one side, sine rule is good. Let's say you know three sides and you want to find one angle, cos rule is good. Getting it? So it is just a mathematical tool to figure out the sides and angles when you need. There, this is all the trigonometry you need. So this is called properties of triangles. Clear so far? Any doubt so far? Anything you're not clear, please ask me. Take a break, take a 5-minute break, come back by 9:35. We'll continue from here. You can keep your cam off, you can just go away from the screen for 5 minutes and come back. Any doubt so far, you can ask, or else go. Just take a break for 5 minutes and come back. Okay, come back in 5 minutes then. Chalo, let's start off. Great. Let's do a question on this. So we got a block here. So we have a person here who is holding the one end of a string. We did something like this. So we have, so there is a block over a pulley and you are holding this on one side. Then what you did, you started walking from here to here. Let's say this is A and this is B. So when you started walking from A to B, the string becomes like this, the new red dotted line. And in this process, I hope everyone agrees here, the block must have moved down, isn't it? Let's say this distance is 10 meters. So man walks from A to B. Holding one end of a string. And the other end is connected to a block over a pulley. And in this process, what happened? This angle, which used to be 30 degrees, this angle became 60 degrees. Yeah. So find the distance moved by the block. I'm sure most of you do remember this. We have done something similar in foundation, but yeah, we can do it again. But is the question clear, everyone? You're catching one end of a string and you're walking from A to B 10 meters. So when you go from A to B, the angle has changed from 30 to 60 degrees. So in this process, this block will not stay at the same position. It will come down a bit. So indirectly, I'm asking you to find this distance here. How much did the block come down when the man walked from A to B? Anyone not clear with the picture, please ask me. What's the idea here? Again, see, don't get confused between maths and physics. So what is physics? Figuring out what is happening is physics. And then maths will come to help you to get that. Meaning, just to give an idea in case you didn't figure it out. Listen, tell me one thing. Imagine this length of the string here. Example, okay, just a random number, 20 meters. Let's say that length is 20 meters. And when he started walking, let's say this length becomes 13 meters. Just random numbers. So my question is this. If this was 20 and if this was 13, what happened to the remaining 7 meters? Must have gone somewhere, right? You're getting the logic? Initially, if this was 20 and if this was 13, what happened to the remaining 7? It must have gone somewhere. That means this guy must have gone 7, isn't it? You're getting the idea? This is physics part. Now your job is to figure out what is this length and what is this length. And if you subtract them, you're going to get your answer. Isn't that the logic? Now max will come to find you those distances. So that is when max will come. But if you can't figure out that the difference in distances is the distance mode of the block, then you can't do anything. Right, Anish. Right, Karthik. Nee, Rohit, that's not the answer. Try others. I'll give you a minute more. Same question we did before in foundation. So yeah, so there I think I gave you 2 meters or something. So don't worry, others. So if you're taking time, it's fine. Like some of these questions you have done before, so it was fine. Right, Ishi, you got it. Okay, let's see again. But you got the logic there. So the logic was you need to find the difference in the distances. So let's call this point as P. So this is the thing. The difference, the distance moved by the block is nothing but the difference in length of the string from man to the pulley. In this case, that is nothing but AP minus BP. Agreed? This is AP, this is BP. We are neglecting the height of the man. Clear? So now if you draw a triangle here, so this is A, this is B, and this is P. This angle is 30 degrees. This angle is 60 degrees. So this has to be 120 degrees. 30, 120, 50. So this has to be 30 degrees. Luckily, you can clearly see this is an isosceles triangle. This is 2 meters. So I can use sine rule here. So what is the sine rule? Take any angle. So for example, if you take sine 120, the opposite of sine 120 is AP. So take a side, divide by the sine of the opposite angle, which is sine 120. Take BP. For BP, what is the opposite angle? 30 degrees. That's your sine rule. You choose any side and take the opposite ka sine angle, and then you just divide it. Then you take AB, and the opposite angle is sine 30. There. So if you try to solve these two, you can clearly see AB is equal to BP. Obviously, right? Because there's an isosceles triangle, they have to be equal. If I take the other one, AP and sine 120 is root 3 by 2. AB is 2 meters and sine 30 is half. 2 will cancel. We'll get AP is equal to 2 root 3. Please check. It's all calculations there. So if you do that, your job's done. So this is, sorry, why am I writing 2? It's 10 meters. My mistake. This was 10. You're done. So this would be 10 root 3 minus 10. You can leave the answer like this, 10 into root 3 minus 1. So the main idea is to figure out that AP minus BP is your distance traveled. Once you got this, then Max will come to figure it out. Are you clear with this? Clear, Dave? Tanmay? Clear? Rohit, got the mistake? Prisha, got it? Ahana, clear? Ananya? Taksha? Great. Let's see one more. I hope you guys are noticing something, right? I'm teaching you the basics, but the questions look quite different and weird, isn't it? This is what I was saying. So don't get confused between max and physics. Max is simply a tool. We are going to use it a lot, but without understanding the physics part, you can't use max. So we have a hollow cone here. This L here is your slanting length. R is the radius. Let's say let's say R is 1 meter. Length is 3 meters. Okay. Perfect. Now in this corner, this is point A. Now what happens here? We have an ant. This ant starts walking around the cone and comes back to point B. B is the midpoint of this side. You're getting where is B? So A and B are on the same side, left-hand side. It is on the midpoint of that. So the ant goes around the cone and comes back. Now understand one thing. The ant can do this in infinite ways. The ant can go like this and go here. Ant can go like this and go here. Ant can go up and then come here. You're getting it? Ant can reach B in different ways. There are infinite ways ant can go from A to B. But among all these infinite ways, there is one path with the shortest distance. Make sense? There will be one path with the shortest distance. Find that minimum distance. An ant goes around the cone. It has to go around the cone. Huh? You can't go directly here. You could have gone directly, but I don't want that. I want the ant to go around and reach there. So an ant goes around the cone from A to B in a shortest path. B is the midpoint of that slanting length. So I will take this point as so basically A, B, O are in a straight line. We use the word collinear. I hope you know what it is, meaning they're on a line. AB is equal to BO, and it is a midpoint, so L by 2. Find the length of the shortest path. Meaning if I have to show you the different possibilities, this was A and this was B, you could have gone like this. You could have gone like this. You could have gone like this. So there are infinite ways you can go. You just have to go around, take a turn, and reach there. But among all these paths, there is one shortest path. What will be the length of the shortest path? If you guys remember in foundation, we did this question. The ant goes around the cone and comes back to the point A again. That's what we did then. I just changed it a bit. Let's see. Now, how do you handle this? Think for a minute, then I'll tell you something. Then I'll give you 2 more minutes. The first thing, understand like, okay, how the hell do you even start? That's completely fine. Huh? That is how it always feels. So that's what you have to find, Anish. Why will I give you that angle? Okay, I'll tell you what is happening, then I'll give you more time. See, first of all, the problem we are facing here is because this ant is going in a curve, I have no idea what is actually happening. But we studied something in school. The shortest distance between 2 points is what? A straight line. in a plane, you're getting it? There is a word there. On a piece of paper, on a flat surface, right? If you take a flat surface, the distance between 2 points is a line, isn't it? But the problem we are facing here now is because my ant is going in a 3D structure, it's becoming really difficult to visualize how it is going. So somehow I need to make this into a flat surface. So this is what we're going to do. So that is the idea there. Whenever you handle 3D structures, whenever you see things moving on 3D, we can't visualize it. We can't do it. So what you have to do, somehow you have to make it into a flat surface. So take a scissor and cut it on the corner. Now, if you cut it here and if you open this, what do you think you'll get? If you cut a cone from the corner and if you open this, what shape do you get? You will get a sector. How do I know it is a sector? Think about it. This point is O, this point is O, this point is A, this point is A. If I mark any point on this circle, those points will be here, isn't it? This length is L, this length is L, this length is L, this length is, aren't all these are slanting lengths? If all the points are equidistant from the center, isn't that a circle then? And because it is a sheet, it will form a sector. So when you cut open a cone, what you get is a sector. This is your sector. So this corner is point A. Can you tell me what is this corner? That corner is also point A, isn't it? Because you're cutting A into two pieces. So can you guys tell me where is B now? There is one B here. There is one B here. B also will become two pieces. Making sense? If you cut through a point, you actually create 2 points. Now you want to go from which A to which B? You want to go around the cone, isn't it? So you need to go from here to here. Isn't this what I'm asking you? Because if you make the cone into a flat surface, now I know the shortest distance. What is the shortest distance? The line joining the 2 points, that is from here to here. So if you can find the length of this black line, my job's done. And be careful, this is not 90 degrees. This is not a right angle triangle. Maybe I drew it like that, but it's not a right angle triangle. There, this is a physics part. At this point, physics gets over. Physics will tell you, boss, if you can find this length, your job's done. You get the answer. Now Max will come and try to figure out how to find the black length. Figure out. You got a minute or two. Ishi. You type some answer, Ishi. All I can see is a dot. Okay. Let's see. I don't know the answer for this. So even I need to check it out. I think, but you and Ahana got the same answer. So maybe right. Let's see for a minute or so, and then you will do it again. In the meantime, you can do one more thing. Like, don't sit idle. Can you do what will be the distance traveled if you go from A to this corner? The diameter. Let's get that. You guys can do that in the meantime. If I want to go in the diametrically opposite point, then what is the shortest distance? So that's like A to C. Others, let's find AB. But anyone not clear with the so far whatever is explanation, please ask me. So when you cut open a cone, you get a sector. You can try this. You can make a sector at home and you try to fold it and you'll get a cone. How do we get angles? So let me help you a little more. Look at this picture here. If you take this circle at the bottom, the green one I'm shading, isn't that circle and this one the same one? Same thing, right? When you cut it, the circle becomes an arc. And what is this length here? This length is 2 pi r. Agreed, because this is the radius r. And this is the slanting length L. So that is your length L, that is a radius here. So for this sector, we get a radius L. And if you take this angle is theta, we studied this concept today. The first concept, what is the first concept? The angle theta is the arc length by radius. So here the arc length is 2 pi r. So for this sector, the arc length is 2 pi r. And for this sector, the radius is L. I will not use S and R because the words can be confusing already. So that's your arc length. That's the first concept we learned today. So here the arc length is 2 pi r for this sector and the length is L. And the values are given, right? Radius is 1 meter and length is 3 meters. So 2 pi by 3, that's actually 120 degrees. 2 pi by 3 is 120 degrees. So this is 120 degrees. So the triangle OAB is actually a 120 degree triangle. Now what? Now how to find AB? See, whatever I taught you, everything is coming. So I gave you the angle. And I also know this, remember, OB is a midpoint, right? So this length is also L by 2. Now, can you guys do something? I know the angle, I know two sides, and I need to find the third side. Which mathematical formula will give you a relation between three sides and one angle? Cosine rule. Cosine rule formula will give you a relation between one angle and three sides. Is that clear, everyone? So that is how you start connecting everything. Like I said, Max will just give you the lengths and everything. It doesn't know about opening the cone, cutting the cone. That all story, Max will not have an idea. That all we have to figure it out. Okay, I think you guys changed the answer to 3 root 3. Let's see. So once we got this, I'll just put a new triangle now. So we got a triangle. This was 120 degrees. This was O, this was A, this was B, this was L, this was L by 2. I'll call this X. So just for your convenience, I'll write this as A. So this will be small a, this will be B, and this will be C. So what's the formula? Cos A is B square, C square minus A square by 2BC. So cos A is cos 120. B square is L square by 4. C square is L square. A is X square. That's what I need to find. 2 into L by 2 into L. Cos 120 is minus half. This would be 5L square by 4 minus X square by L square. This is minus L square by 2, 5L square by 4 minus X square. So this will be X square, 5L square by 4 minus L square by 2 multiply 2, that will be 3L square by 4. We get X is equal to root 3L by 2. So we got X is equal to root 3L by 2, but L is given as 3 meters, which is 3 root 3 by 2. I hope I'm right. Check. Did I goof up some calculations? All of you got 3 root 3. Did I do some calculation mistake? Did I mess up somewhere? Because I think 2 to 3 of you got 3 root 3. I'm now doubtful I might have messed up. Please check my calculations. I messed up, let me know. But you got the concept right. So calculations, you can figure it out. You also got the same, Anyoka and Anish got the same. So we are 2 and 2. Karthik, you got the same? There, I think I must be right. We have 3 people in our team now. So Ishi and Ahana, figure it out. See if you guys did the same thing. But I hope the concept was clear. So pretty neat question. Even if you see, tell me one thing. Did I teach you any new concept to solve this question? Every concept you already knew. But the thing is that only, see, these things you cannot learn them by watching recordings or by attending 10 classes you can attend. Only when you actually sit and try to solve questions, these kind of things will slowly develop. It will take time. Maybe today you might be finding like, oh, how can I think like this? But when you learn like this for 3-4 months, you will think this is normal. That's the whole point. It's not like your school ka physics, right? School ka physics is boring. We don't teach that. That's not physics. That is something else. Anyway, so the main idea was what? The main idea was that I can open the core and make it into a flat surface. That's the biggest idea there. Once you got that, then it's all about a math. We need to figure out this angle that came from s is equal to r theta. And once I got theta, then I use my cosine rule. Max is important, but that is secondary. It comes after what you did. All clear with this? This is how you get trigonometric applications. Great. And after this, we have something called an infinite GP. This I have done in the foundation, but I'll just brief it up again because this is something which keeps popping up multiple times. Like I said, I'm just teaching you all the things that are required for physics. So we're not going too deep into the mathematical aspect of it. We're just interested in, okay, this is the formula for this. So you saw cosine rule, we used it. How we got cosine rule, that we are not interested. It's like, you know how to use your phone. It does not mean you should know how a phone is made or how a phone works inside. So what is geometric progression? So we have s of infinity. If you have ar power 1, ar square, ar cube, plus so on till infinity. This is called sum of infinite terms. In maths, you will learn much more, AP, GP, all that stuff. But for physics, we are happy with this much. Let them teach you then. So when you add all this, the formula comes out to be a by 1 minus r. So this is valid when r is less than 1. That's it. Simple, straightforward. This is the formula. If I give you a sequence like this, when you add all this is the answer you're going to get. Example. Let's say s of infinity. If yeah, one more thing. What is a? A is your first term. What is r? R is actually the multiplying factor. Like, r ka value lies between 0 to 1. It can't be negative. So r ka value is like this. Second term by first term. So it's a ratio of the next term by the previous term. Third term by second term. So on, you can see the sequence here. It will be nth term by n minus 1th term. N can be 100, 200, anything like that. So r is the factor which keeps getting multiplied every time to the digits. You can note down that formula. We will need that. Example, let's say s of infinity 2 by 3, 4 by 9, 8 by 27, and so on till infinity. You can clearly see this is 2 by 3, 2 by 3 ka square, 2 by 3 ka cube, and so on. So here a is equal to 2 by 3, the first term. And what is the multiplying factor? You can clearly see every time it is getting multiplied by 2 by 3. So that is also 2 by 3. So what is the formula? A by 1 minus r. So that would be 2 by 3 by 1 minus 2 by 3. That's 2 by 3 by 1 by 3, which is 2. Understood how to use this? Easy, straightforward. This is called a sum of infinite GP. Let me show you one more example. If r is greater than 1, then the sum of the terms will also become infinity. Right? So think of like this, Anish. When you add infinite terms, why are you getting a constant value? That is because as the numbers are becoming, more and more numbers, these values are contributing very small value, right? So even when you add infinite numbers, still you get a finite value because the last numbers are not contributing much. Any doubts on this page? Clear, na, Prisha? Rohit? Tanmay? Shrikant? Ananya, Daksha, clear? So great. So what we'll do, I'll give you some examples. You guys tell me what is the answer for this. S of infinity, let's say 506, 5 by 6 square, just so that you get used to it a bit. 5 by 6 whole cube, so on till infinity. Yeah, just add them, give me the answer. Yeah. You remember the formula? A by 1 minus R. A is the first term and R is the multiplying factor. Just focus on solving. Don't worry about writing all this stuff. That's what I was telling you. Your job is to listen and absorb as much as you can and spend all the time thinking. Because if you see, right, barely, what did it really teach you? I taught you like one or two concepts which you already know. What we're trying to do is how do we actually use this concept to, do different varieties. So let's see here. So the first term here, A is 5 by 6. The multiplying factor is also 5 by 6. Hope everyone has seen that. So the formula is A by 1 minus R. That's 5 by 6 by 1 minus 5 by 6, which is 5. So here A is sine 60, which is root 3 by 2. You can leave the answers in roots and fractions. That's okay. R is also sine 60. It's always getting multiplied by the root 3 by 2. So the formula is A by 1 minus R, which is root 3 by 2 by 1 minus 2 1 minus root 3 by 2. That would be root 3 by 2 minus root 3. Yeah, you can rationalize it, but it's okay. Leave it. Don't worry about it. Not a big deal. A is tan theta, which is 1 by root 3, and R is also tan 30. One by root 3 by 1 by root 3. So that's 1 by root 3 minus 1. Easy stuff. All got this? Any doubts on this? Clear, na, Dave? Dave? Perfect. So, yeah, so that's an easy stuff there. So let's see one question. So we got a ball here. The ball is dropped from a certain height. So this ball comes, hits the ground, and it bounces again. But this time it'll bounce to a less height, it'll bounce to a less height, it'll bounce to a less height, and so on. Now, technically speaking, they should be all on the same line, okay? But if I draw like that, you can't see. So I'm putting little to the side. So the ball is dropped from height h. After hitting the ground, it bounces to 3/5 of the previous height. You must have noticed this, right? When you drop a ball, it doesn't come back to the same height. So after hitting the ground, it bounces back to 3/5 of the previous height. So every time you collide, you only go 3/5 of the previous one. Find the total distance traveled by the ball. That looks wrong, right? Rishi? Rohit, that also looks wrong. Karthik. Okay, you guys are getting this. Nee, Karthik, it is wrong. Nee, Rohit, that is also wrong. Try. Take your time. Take a minute. Aram se kar. Right, Ishi, you got one answer. Finally, the previous one was wrong. I think you forgot to add something. Again, you can clearly see this forms an infinite GP. Must have seen, like, every time it becomes 3/5. This is how they will frame stuff. No one will directly ask you the GP ka formula. It always comes as a part of something else. Right, Anish? We have two answers. Yeah, right, Rohit. Got it. That starting part, you have to be careful. So, what's happening here? See, the first time you will fall H. Second time, you're going 3/5H. And remember, you're coming back again. So 3/5H. It is counted 2 times, isn't it? Because I said find the distance traveled. When you go up and come down, it should be counted 2 times, isn't it? If you go 5 meters front and come back 5 meters, how much did you travel? 10 meters, right? Distance, not the displacement. Next time, how much will this be? This will be 3/5 ka 3/5. That is 3/5 whole square. H. And so on. I think now you got the sequence. Now we can clearly see the distance traveled will be H plus 2 times. So the first one will not be 2. The 2 comes after that. 3/5H will occur 2 times. 3/5 square H. Remember, it is not H square. Huh? The 3/5 only gets multiplied. 3/5 whole cube H and so on till infinity. So this would be H plus take out H common. So 3/5, 3/5 square and so on. So where is the infinite GP? Infinite GP is this guy, not from the beginning. So here is 3/5. The multiplying factor is also 3/5. So the formula is A into 1 minus R, which is 3/5 by 1 minus 3/5. That's 3/2. So this was H plus 2H 3/2. That's 4H. All clear with this? Yeah. You have to be careful here. Most people either they will forget to multiply into 2 or they'll multiply 2 for this guy also. So things can go wrong. So you have to be careful. Easy? All got this? Let's see one last one and we'll wrap up for the day. Another easy one. So we have a lot of resistors. 3 ohms, 9 ohms, 27 ohms, 81 ohm, and so on till infinity. This is an infinite ladder. So we have an infinite resistors in parallel. Find the equivalent resistance. I am sure you studied in school, right? Series parallel. So you have infinite resistors in parallel, 3, 9, 27, 81, and so on. Find the equivalent resistance of this system. Ah, okay. Let's see. Okay, someone got 2, someone got 0.5. You have to be careful. Be really careful. Yeah, not a tough thing, but they will. Yeah, Anish got it. Right. Right, Prisha, you got it. Ishi got it. Karthik got it. You guys remember the formula, right, for 1 by R equivalent? So when resistors are in parallel, 1 by R equivalent is 1 by R1 plus 1 by R2 and so on till infinity here. So this is 1 by 3. Now, see, 3927 is also a GP. But if you take 3927, it actually becomes R greater than 1. This is actually inverse of it. There you can clearly see A is 1 by 3 and R is also 1 by 3. So the formula A by 1 by R is 1 by 3 by 1 minus 1 by 3. That's 1 by 2. But now be careful here. What did you get? You got 1 by R equivalent is 1 by 2, isn't it? You didn't get R equivalent. What you got was 1 by R equivalent. Therefore, R equivalent is 2 ohms. Now, unfortunately, in the exam, the first option will be 1 by 2. And because you are in a hurry or you got so excited you got the answer, you'll mark that 1 by 2 and you'll go ahead. You might think like, oh, I won't do such dumb mistakes. You will do. You know what was my favorite mistake in 11th and 12th? 3 into 3 is 6. I did this multiple times in my 11th and 12th. Final exam, I went and did that in the chemistry paper and came. 2006 JEE advanced exam, I did that in my chemistry paper and came. Right? We really do some happens. See, understand 3 hours, you will be under complete pressure. You have to do a lot of questions. Dumb things happen. And as I was telling you, right? One of your senior 12 minus 8 or 20 and came. Happens a lot. So can't do anything about it. Another guy, one of your senior, he did this also. He wrote 23 like this and he thought it was 2 cubed. When solving, he got 23 as an answer. But while thinking, he thought it's a 2 cube and he wrote 8 in game. And now tell me what is the remedy for this? There is nothing you can do about these kind of mistakes. So happens. So that's what, in an exam, normally 2 to 3 silly mistakes are acceptable for the whole paper. So if you're doing 1 or 2, it's okay. Clear with this? So that's a little about infinite GP, right? We need only this much. We will not go more than this. Like I said, it's just a basic math ka thing. I'm just trying to show you all the important things we require. So next class, when we catch up, we're going to do something called coordinate system. I'm sure you already know about Cartesian, X and Y. We're going to see in 3 dimension, X, Y, Z, and then we're going to learn something called polar coordinates, right? And then I think next week onwards, we will start off with a chapter called vectors. So that will be our first official physics chapter. After vectors, we will do calculus. Now, again, calculus is completely math. In differentiation and integration, you have not learned anything like that in school. That's, again, very important. Without calculus, you can't handle advanced papers. So that is there. And we will go on vectors, calculus, then we'll go for kinematics and so on. So we'll be focusing primarily on mechanics in the starting part, which your institutes also will do the same. So the starting chapters will be exactly same. Portion will match, so don't worry about it. In written, actually, they will go a little ahead of us. That is okay. Okay, with that, we'll wrap up for the day. So I'll see you guys again on Wednesday. So first thing, after today's class, I know it's 10:20. Tomorrow, spend some 20 minutes, take a rough paper and just try to solve them again. Especially this Konka question. Right? You have Konka question, try it again. And then try to do again in the 2 homework questions I gave you. So take a rough paper and just try to do it. You should do this after every class. Take a rough paper and just solve the questions again. If you can do it, great, you remember. But if you can't do it, that tells you something. You learned something yesterday and you forgot in a day. You might think that won't happen to you, but it is very common, happens a lot to everyone. And that is how you remember. And this is not what I'm telling you. There are people in, in Harvard or Princeton University, they did a research. They saw how much does a person remember. So this is what they found out, okay? After the class gets over, the decay starts immediately. The brains are designed to forget, because if you remember every damn thing in your life, you'll make your life miserable. That's your superpower, right? You can forget all the nonsense that happened in your life, right? Just imagine all the embarrassing things you remember in your life. Like, you're not going to feel good. So half the times you forget about it. So this thing decays, and they found out within 24 hours, this thing drops to almost 10%. Within 24 hours, you forget more than 80 to 90%. Never think like you'll remember. That's, yeah, if you might be an exception, but maximum people it happens. What they suggested is, if you can revise within 24 hours, this thing goes up. But then again, decay starts. Decay always starts, but this time it goes a little slower. It takes a week. So if you can revise within a week, again, you can push it up. But this time it takes almost 3 to 6 months. So every time you revise, the decay actually slows down. If you revise again after 6 months, it stays more than 2 years. And that much is sufficient for us. So every chapter will go to at least 2 to 3 revisions. So yeah, that's the thing you need to remember. Plus, I'll also send you a small sheet also, maybe not much, 20-25 questions, you can give it a try. Okay, with that, we'll wrap up for that day. I'll see you guys again on Wednesday. I'll send you the notes and I'll send you the recording also. So if you want, you can go through that also. Right. And regarding the testing and all, I will give you access in the next week. We will start the test after 2 weeks. Okay, with that, we'll wrap up for the day. If anyone has any doubts, any questions, you can please stay back and ask, or else you are free to leave. I will be the last one to leave, so you can disconnect.